ProClimber inspires and educates people to create healthy, durable and energy-efficient buildings to live, learn, work and play in. Welcome to the ProClimber podcast. In today's episode, I speak with Dr. Antony Pelosi. Antony is a researcher and educator of architecture at Victoria University. In today's podcast, we discuss the use of artificial intelligence and how this technology can be used in architecture. Hey there, Antony. Thank you for joining me today. How are you doing?
Good, thank you.
Fantastic. Now, Antony, just going back a little bit, you started off your career first by studying building science, and then you did a second degree in architecture. What inspired you to go down building science and architecture route?
I'll go back even a little bit further. Back when I was a high school student, I definitely struggled through my education, thought about becoming a builder or something like that, and even worked during the holidays on building sites. And sort of just towards the end of my high school time, I decided actually let's give university a go. And back then, I think it was the last year, the way the architecture degree went, you did the Bachelor of Building Science first, or along the way, and then the last 2 years was architecture. So it was sort of all together in essence, but that's sort of the way the degree structure worked. It's changed a lot now, where that took me well over 5 years for a number of different reasons, but now you get a master's degree after the 5 years. But we've split the building science and the architecture programs into different degrees. When I was a student of those at university, we sort of didn't pay as much attention as I probably should have to the building science content. I see the value in that now and understanding the science of how a building works and the importance of getting that right. And I'm still interested in and glad I did that back all those years ago now.
And then you went over to America and studied in California. Tell us about that.
Gosh, that was a while ago. It was I figured it out the other day. It was nearly 30 years ago, which is pretty scary. Victoria University of Wellington has a really good exchange program with a whole lot of other universities around the world, and you pay fees here and you get to go study in another country. I was fortunate enough with a couple of friends actually were able to go over and study at University of California, Berkeley, just outside of San Francisco, and was able to live and study there for a year. And it sort of opened my eyes to how other parts of the world operate and that in New Zealand, and I think we still do this to a degree, we think we're at the bottom of the world and everyone else is better or those sorts of things. But actually going over, and while I was an undergraduate student at that point, I was put into their master's program. So in essence, did a year of the Masters of Architecture at Berkeley. And it just opened my eyes, and I've still got friends from all around the world. I was fortunate enough to stay at a place called International House, and there was amazing people from all around the world that had come to study at Berkeley. So yeah, an amazing experience really.
That's really cool. And then you went to do a PhD. What was the focus of that?
Went to Berkeley and then came back and finished my Bachelor of Architecture, and then went back and lived in America for a few years in San Francisco and worked for an architecture practice called Holt Henshaw. That was early 2000s, just after the dot-com bubble burst, and sort of was like, I think I'll come back to New Zealand with the intention actually of going and mountain biking and snowboarding in Canada, but that never actually happened. And getting a job here in New Zealand at Massey University, and part of the deal with that was that I continue study, and I started out actually doing my master's at RMIT in Melbourne, sort of via distance. In that process, I sort of turned my master's into my PhD, and back then we had PlayStation portables and sort of gaming technology was just starting to develop, and I could see that the sort of 3D environments and BIM was just starting. we had these sort of 3D models, but we were still outputting everything to drawings and 2D things. My PhD ended up being around, sort of started with the idea of how would we interact with these 3D models? And this is pre-iPhone, pre-iPad, realizing that we'll have these 3D models and that we'll be able to access them on site. Having a PlayStation Portable that you could navigate this little model on, how do you interact with it? Because drawings don't work for that because they're set up at A1, whatever big sizes. How do we sort of have this? So it started with that, using game engines and sort of through a series of iterative design explorations, I guess, of using the technology and thinking about what does a section look like in a 3D model? How do you interact with these sorts of things? And during that process, realizing that we still get lost in these models, that we become disoriented, you get stuck in the wall, like, where's the whole building gone? So I ended up sort of creating a number of strategies that helped us understand what we're looking at in that 3D model. So my PhD ended up being around spatial comprehension inside BIM digital models. And I created a framework. I can't remember it all off the top of my head, but basically thinking about how we can support people in these 3D environments, especially if they're like a builder or a contractor that's never seen the project before and they're just trying to get an understanding of it and being able to provide assistance. So having a grid, really simple things like a grid that wherever you are, it's set at a meter. So you can quickly see, I can see 3 squares. So the room's 3 meters, like without having to think about it too much. Also using AI, funnily enough, way back then, this is probably 2010, I started doing that, using AI to help with pathfinding. So you've got this 3D model, you have never seen the building before or understand it, hasn't been built, so you can't go and see it. Rather than just zooming to a space in the model, it can walk you through the building, so you build up that spatial understanding of it. And it just uses a AI pathfinding algorithm to figure out the best pathway to do that. And that also came from the gaming world, so they use a lot of those things for helping people move through.
I don't think AI was even a term any of us would have been hearing about back then, was it?
No, not compared to the way it is now. I've been playing and dabbling with AI for quite a while.
Now, Antony, we were talking earlier and you were saying that you're busy designing and getting ready to build your own house. And you were mentioning a crazy number of 300,000 for over 100 square meter. That sounds amazing. Tell us about that.
I'll just give a bit of the backstory. I'd been renting for a couple of years and I was thinking, I should buy something and do it up. And I was looking at places, and to be fair, they were all expensive and pretty shitty at the price point that I was looking. And my son, Max, actually, or one of my sons, Max, said, why don't you build something? And I was like, oh. And I found a section and started looking and did some quick numbers and talked to a few people and said, oh, yeah, that should be possible. And this particular section wasn't right. And then so I kept looking and found another section that a couple had subdivided. And so they're keeping the house in the front. And I ended up buying the section in the back. And it had an existing garage there that allowed me to sort of not have to pay for a garage and some other things. And it just sort of made the numbers work a little bit better. So I forced myself to learn Revit over the summer, basically, and build a 3D model of the whole thing. And I gave myself a budget of 300,000 for the build, partly because of what the bank would lend me, partly just so I don't put myself in too much debt. Also, a little bit of a challenge. So the plan was to, or is, I guess, still to do, is build a passive house that is Homestar 10 that comes in at around 300,000. That sort of requires me to do a lot of the work. But so far, I'm close to that. I've had to pull some bits and change some things. That won't be including decks and some of the extra bits. But yeah, I think I can make it work. And I'm doing that by keeping it really simple. So it's a really simple rectangle shape, 15-degree roof, everything's sort of lined in plywood that I can do myself. So I'm not having all these other things going on, trades needing to come in or anything. I've been keeping an eye on specials and things like that. So I've managed to pick up a whole lot of bathroom fittings and plumbing fixtures at a reduced price, and just being smart about where I put windows and things like that. So trying to spend the money on quality windows and good insulation and thick insulation, and using good building wrap products and things like that as well.
Oh, that sounds like an amazing project. I'm really looking forward to following you on that. Getting on to the topic that we're planning to speak about today. Now, artificial intelligence is really all around us at the moment. It just seems to be the buzzword that everyone is talking about, and just it grows and grows at this fantastic rate. I mean, we saw, first of all, the launch of this thing called ChatGPT, and just incredible what that can do. And then we saw the image generating tools like DALL-E and things, and then that moved into video. Can you maybe just step back a bit, especially understanding now your history with AI? Can you just give us a little bit of a basic understanding of how do these tools actually work?
They work in different ways. The easy answer, I think, is no one actually knows. The harder answer is it gets quite complicated, and there's quite a lot of maths in the background that drives sort of assumptions. So there's a lot of coding built in. We'll just look at text, for example, where it'll look at what's the most obvious next word given the bigger context. And that's, again, a really simple answer, and it's way more complicated than that, because the answers that come out when you put in the right prompts are pretty amazing, but they are learning by all the text that's out there. So basically, someone codes a set of instructions for a machine, the computer, some software to go through and analyze a whole lot of text or images or video and figure out how it's compiled, and uses statistics, I guess, and probability calculations to figure out how these things all relate. That's about the level that I operate at. You probably really need to talk to a computer scientist that is coding some of these things to give you a more in-depth answer.
Oh no, that was a great description, Antony. Now, how are these tools being utilized now in architecture and design?
Something just popped into my head back to the other one around the image generation. I saw a really good little piece about if you ask AI to generate an image of a clock at a specific time in an old clock with hands, it can't do it because most of the images of clocks and watch faces, one of the hands is on 9 and one of the hands is on 3. So it doesn't understand how that operates as showing time. It just understands that it's a clock or a watch face. It doesn't have understanding beyond seeing a whole lot of pixels, basically.
That explains it really well, and gives you some of the idea of the limitation of this, isn't it? The bigger history of what's out there at the moment. And it's using the averages across of what it can find and then utilizing that to try and answer your question, isn't it?
That's a lot of the public-facing stuff that's available at the moment. There's a great documentary called AlphaGo about Google's DeepMind. And this is quite a few years ago now. And that sort of follows the DeepMind team as they build an AI to compete against the world's best Go players. And Go is a strategy game that have these little counters. And what's really interesting with that is in this game where they play this person, that it comes up with a move that no human would come up with. So DeepMind comes up with this move that wins the game, but a person would never come up with it. I was talking to my son Max last night about this podcast, and we're just talking about these things. And he also mentioned like the best chess AI is just insane. compared to a human. So it's doing things that humans just wouldn't do. And that's where a lot of the public-facing stuff is probably going to end up, doing these things that we just can't comprehend. But we're a wee bit away from that, I think.
Totally. Moving forward into architecture and design, where is it being used and what is it doing at the moment in that sphere?
It's been used in a number of different ways. If we go back to the idea of text, image, video, and even 3D, I've spoken to a few architecture companies predominantly around AI in private conversations, and there's definitely practices using it for report writing and bid proposals and things like that. And some of the numbers I'm sort of hearing through conversations and also beyond is that it's saving them 50% of the time because they can write things faster. I'm definitely using it for my writing, and I'm seeing I can crank things out really quickly. Usually it's a good first draft, and I have to go through and tweak and edit it, but it gives me something to operate with. So I think from a text level, there's those sorts of things happening. And image generation, there's definitely companies using it for concept ideas and rendering. There's some of the bigger architecture practices globally are building their own AI, large language models and other AI machine learning sort of databases. I think that's useful to a limited degree in the sense that it's just putting out a whole lot of pixels. And like the analogy of the clock, it doesn't know what it's actually creating. It doesn't understand the spatial qualities of it, the structural qualities, the thermal qualities, the buildability of it, if it's even buildable. But I was listening to another podcast today, this morning, and they were talking about similar sort of topic. And as a quick way of doing some rendering that 5-10 years ago, you would have spent weeks running something to render it, or you would render it all in Photoshop or even watercolor. This is doing it in seconds, really. So it's taking something that used to take a long time and doing it really quickly. So the option to change how we think about design is there. I would say the tools are still quite sort of early in their development, and they've, even in the last year or two, they've improved massively. And then there's a few platforms now starting to get into the 3D world. So you can text to 3D, text to BIM, just sort of starting to happen. And I think that's where the real value is starting to come into the industry, in that I'll use a BIM model as an example, just to lay that out and set that out. Can take quite a while, where there's a company called Hyper that they sort of did this test, I guess, where it's text to BIM. And they use the example of a 4-story apartment building that's 20 meters by 10 meters on top of a concrete podium that's blah, 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 and stud height is whatever, whatever, and it will build the model for you, as that base model. And things like that are only going to get better. But is that AI, or is that actually just sort of automating something in a way that can understand it? So there's a few sort of nuances around some of these things. It's just sort of understanding the language, but it's just then using automation to generate all the stuff at the other end. So, yeah, there's a few ways. And I'm seeing students, it's been interesting being able to watch and talk to students about how they're using some of these things. And back to the text-based stuff, that you can get AI to create a spreadsheet for you. So I want a spreadsheet that gives me all blah, 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 and it will generate it for you. So rather than you manually setting up a spreadsheet, it'll generate that for you straight away.
So just to drill into that a little bit deeply. So we talked about using text prompting to give you perhaps a concept drawing of the building. Can it then take that concept and start actually putting details together around the building?
Yeah, there's a few services, let's call them, that are starting to do those sorts of things. There's a website called AI in AEC or something like that, or AI Hub or something like that. On there's a list of AI apps for AEC, and there's over 1,600 of them. So it's really difficult to keep up to speed with all of these things. There's a couple I saw the other day. Well, there's a few that I've been keeping an eye on that will generate floor plans for you. I haven't looked into these ones specifically that will generate details. I would definitely be cautious of things like that at the moment still. Like the amount of complexity that goes into a detail is pretty crazy. But if we look out a few years, I have no doubt some of these things will be doing probably details better than what we are doing now.
Talking about your students, how is the university actually managing to prepare students for this environment, which is really changing so fast? And how do you develop material?
It's difficult. I think it's a two-way thing. It's us figuring things out and giving it to the students to use. It's also talking to the students and finding out how they're using them, because they often have the time to play with the tools. I'll give some examples of what I'm doing. So there's the summer course that I've taught the last couple of years called Design Thinking Business. And this year I set up a custom GPT for it. So I took all the content that we have. There's a whole lot of videos which I didn't put in, but there's a whole lot of other content that I had, and I created a GPT based on that, and I gave students access to that and said, here, use it. And I showed them how I would use it. So I got it to give me ideas on how to respond to the brief or the projects that I'd given them, how to improve their writing. So getting things to like give me feedback on my project on this, being able to say, well, can you improve what I've done? So uploading what I've done, can you make it better or whatever? Tricks like that. So again, the text-based stuff. There's another course that I'm in the middle of teaching, which is first year Design Studio. And I introduce a sort of parametric modeling and things in that course. And I've set up another custom GPT for that. And that I uploaded a whole lot of instructional books and information on using Grasshopper and also design principles. So getting them understanding some of those and given students access to that. They've literally just submitted that first project, so I haven't had a chance to talk to them meaningfully about how they've used the GPT. I spoke to one student, they loved having access to that and it helped them a lot. So from a assisting learning perspective, I can see as a great help. And especially that course, there's over 300 students. So just giving them sort of access or instructions when they need it, not when I'm available or a tutor's available, I think is massive, sort of on-demand learning, so to speak. Talking to some of the students, they're using it for image sort of work as well. But in the future, there's a colleague, Fabricio, who's sort of been doing some work with colleagues internationally around creating AI platforms. I haven't seen what he's been working on, but his conversations around it, he said, in 2 or 3 years, everything that we're doing now is going to change. I think it comes down to us staying on top of everything that we're doing. And a little bit of exciting news, I guess. I've just agreed to become program director for a new program that the School of Architecture is offering called Around Construction. So we're about to launch a Bachelor of Construction and a Masters of Construction. And so, as you can imagine, how we include AI in this program is massive. So we're just trying to get our heads around what that means, especially for a new course where we're developing new courses. And I think, especially for project management and construction management, how sort of optimizing some of the workflows and running different scenarios through those. There's a New Zealand company that they set up video cameras of a construction site, and then they have an AI layer that keeps track of everything that's going on. So it tracks what the weather's doing, what movement's happening on the site, whether people are using PPE or not. And from an education point of view, we're just sort of in early discussions with them of how we can get students to access some of these things and be able to respond to it and give feedback on, okay, this is what's happened and we've got all this data backing it up. How do we sort of learn from that as well? So it's definitely a rapidly changing space.
Sounds like the AI is really useful in all the different segments of the construction industry. I mean, I can imagine with things like quantity surveying, I would imagine it's helping a huge amount there. Would it be?
Some of the research I did for this podcast, stuff is coming up and saying that. And I think the more data we have, so the more BIM models or smart depictions of things that we have, the better we're going to be around some of these things. So especially, I would say, with cost as well, actually being able to not just have the quantities, but pulling cost information in and understanding that it's not just a quantity, it's actually concrete, and concrete isn't just that much per square meter, but it's also costs this many people and this stuff, and AI will be able to figure that out, I'm sure.
So with the use of all of these AI models, what about liability?
I'm going to be really harsh and say the way we design and deliver buildings isn't working very well at the moment. We've got a global housing shortage. We've got a quality issue of existing buildings. There's a real big boom bust cycle where we go from not being able to get a builder or a contractor to a whole lot of companies going bust because there's not enough work. Something's not right. And I think contractually, there's a lot of opportunity to adjust how we think about these things. And AI has an opportunity to help in that process. But fundamentally, we need to be reimagining all aspects of how we design and deliver buildings, where just because that's the way we've done it doesn't mean that's the way we should be doing it. If we're thousands, hundreds of thousands, millions of houses or homes or buildings short globally, the way we've been doing it's not going to work. It's not going to cut it, especially when we bring in the environmental side of it. When it comes back to liability, I think we need to reimagine that rather than trying to put liability onto individual parties. Can the building take the liability? What does that mean? Does the building take the insurance and therefore the liability? Can there be other ways of checking these things rather than everyone trying to push the liability onto someone else? I don't know what the answer is. I know Chris Moller sort of looked at a different model for the Mount Pleasant Community Centre a few years ago. And I think there's really good opportunities to reimagine those liabilities. And using AI as a catalyst to do that, I think, is a good idea.
And what about sustainability and energy efficiency of buildings? What can we do there?
Lots. I'll look at the tools for a little bit. There's a number of tools. So Cove is one that I was just looking at this morning. Forma from Autodesk is another. And there's a whole lot. There's a Draft, there's Archistar. There's a whole lot that are looking at speeding up, I guess, feasibility studies. And while that may not be directly sustainability, what that means is we can do feasibility studies in seconds now than what we historically have done. But it's giving us ability to do some sustainability analysis early on, way earlier on than historically has been done. Rather than doing a carbon analysis after the building's been designed, we can do it really, really early on and sort of do assumption-based, let's call it, analysis at that feasibility stage. And sometimes that's even before an architect's involved. So developers are sort of running some of these things themselves. Long term, I think it also allows us to reimagine how we spend our time on things. If we're getting these tools to do things faster, it allows us to interact with the design in a different way. What does that mean for how we charge for things? But also that we can run scenarios. I know Warramani are doing some really interesting things where they're running over 500 different design scenarios from a sustainability point of view. So how to optimize a facade, for example, and they're using sort of generative design sort of tools to do that. And pretty much overnight, they can analyze over 500 different design options. Rather than design by assumption, and then maybe checking it after, we can check as we're designing, basically. And then same with materials. We're getting really good databases now of EPD information that we can do quick analysis of those, I guess, and using AI tools or even just automation tools. Back to the comment I made about the liability and contractual things, there's an opportunity here for us to completely reimagine the timelines. So rather than going concept design and schematic design and, going through all of those sort of levels of detail, there's nothing stopping us getting into that level of detail right at the start now and being able to do a really full analysis really quickly. There's a whole lot of opportunity to reimagine both contractually and process-wise how we design and deliver buildings. And I think there's really good opportunities. I had a master's student, Lucy Lee, who was highly commended in the recent NZIA Student Awards, and she worked with a prefabrication company, Hector Eager in Cromwell, and she was able to create her own system, so using Grasshopper and Rhino, that would give her full control of all the wall panels, stud layout, window position, and she could do a design in a matter of seconds and then adjust all of that. And it was giving her cost and carbon of the timber framing as an output. She ended up designing 3 buildings that she could optimize from a performance level to a degree. I'm talking sort of performance in regards to the amount of material in them, so from a carbon perspective, and then also panel size. And it was giving her center of mass of the panels, so automatically. And there's tools out there that do that, but they're usually used at the end of the design process rather than at the start of the design process. And AI is part of this, AI being able to turn the way we do things on its head and being able to know exactly how many studs you've got at any time is really important. Dwayne from Frank House, he's going to do my floor wall and roof panels for my house. He asked me the other day how many studs I've got. And I just looked at my model because I've modeled all of them, like all my studs, and I've got a schedule of them, and I could tell him the exact number and the exact length of each one, sort of in the process of doing building consent. So really early on, I was trying to build some of that knowledge into my own model.
What about energy modelling? Are we able to automate that yet?
The quick answer is yes. I haven't done a lot of testing of that, but the energy modelling is happening in that feasibility study stage. So tools like Forma and things are doing that. So how accurate that is, I'm not 100% sure, but it's giving a direction and feedback. So rather than designing something and the form is really bad, for example, and you get to the end where you traditionally do the energy modeling and you realize, oh shit, that's not very efficient, where now you can go right at the start and get that. So that's not necessarily AI that's doing that. It's just using automation. There's a product called pH Tools, I think, and that's taking Rhino model, so Rhino 3D model, using Grasshopper basically, and feeding that directly into the passive house planning package. So that's automating the information that goes into the planning package. So once you set that up, you can then adjust a window size in the 3D model that automatically updates into the spreadsheet. So it takes a little bit of time and understanding to get your head around that. Guy Ed May basically has sort of generated that. I've sat down and started getting that working, but I haven't got it working for myself in a meaningful way. But as a process, that allows you to have quite an early design, and it will give you quite detailed information out the other end. So not necessarily AI as such, but again, using sort of new tools to do that.
And what about things like robots on our building sites? Obviously, I saw recently a picture of a 3D printer using concrete, I think down near Pukekohe somewhere.
Yeah, I've been playing with this space a little bit as well. I've just had a PhD student, Amano, defend his PhD around 3D printing concrete. That was 2019. We started that process, and then obviously COVID put a big spanner in the works. We've got a large industrial robot here at the School of Architecture, and we sort of work with Callaghan Innovation to look at 3D printing with that, concrete in this case. Done some projects in Amano also using sort of plastic at building scale type things. But he also then, for his PhD, was looking at concrete and clay. So we do quite a lot with clay. Here's another PhD student looking at 3D printing with clay in the robot. And we worked with Korox. They've got a robot arm that's on sort of mobile tracks like a digger, and that can go on site and 3D print concrete. I think there's a real opportunity for robots to be involved in the construction industry. Again, I think it takes a reimagination of what that means and where we should be using them. So 3D printing is one, and I think 3D printing has its place, but from an environmental point of view, you're still printing with concrete, so it's not great for carbon. Even low carbon concretes are still carbon intensive just because of the nature of concrete and the chemical reactions that are going on in the concrete. But at least where you do need to use concrete, you can be much more specific with the amount of material you use because you can apply it really specifically. So for infrastructure, I think there's really good opportunities to sort of reduce the amount of concrete with 3D printing. Robots on site, I think there's their place, but we're still a wee bit away from that, especially from a health and safety point of view and all these other things. There's a colleague, Derek Cafferty, he's sort of doing some really interesting stuff with 3D printing and robots. And I had a conversation with him earlier in the week, and there's these relatively cheap robots that are sort of like a human arm, that sort of size. They have a payload of about 3 kilograms, so you can start to do quite simple things. And so he's exploring all sorts of opportunities there where we can prototype with small robots and then put it out to bigger robots. But for me, it's reimagining how we build. So actually getting a robot to assemble things. We had a student a few years ago, Glenn, who's now working for X-Frame, and he got the robot arm downstairs to manufacture wall panels in his master's, and we thought it would take him quite a while to do that. He ended up doing it way quicker than we thought. He had with one robot arm building 1200 by 24 wall panels. He was working at Makers of Architecture as well at the time, so they helped a lot, which is amazing, and thank you for that. Ended up building a 10 square meter building where the robot built all the panels. The framing, putting a piece of plywood on, battens, and then the weatherboards and nailing. So we've got a nail gun that can go on the end of the robot and it can nail in as it goes as well. So, and then a cutting device on the end of the robot, and it would cut bits out as well. And another student, David, made a really crazy space frame out of timber using a Bodo timber. It was about 50 unique pieces of timber that all had a different angle, and there was about 500 different cuts. So the robot could pick up the piece of timber and basically run it in midair through a bench saw. So the robot we have has got a payload of 200 kg, something like that. And so it didn't need any safety per se around the saw because it's in a closed cell, and it could run this piece of timber in midair through the saw, and it created bird's mouth, complex, compound bird's mouth joints. And it did all 49, I think, pieces of timber in less than an hour, and they were all within sub-millimeter accuracy. The way he'd set up the script is that you could change the design and the full tool path would change. So you're not having to go through all of these back and forth sort of processes to do shop drawings and things. The design is the shop drawing. Again, these tools allow us to do things differently. Then adding AI on top of this, AI will be able to control the robot to do all of these sorts of things. So long term, there's going to be a massive shift in how we build our buildings, basically.
That's fantastic, Antony. This has been a really, really great catch up. Just to sort of finish things off, you've talked a little bit about the future, but overall, in the next sort of 5 to 10 years, where do you see this going?
To be honest, I don't really know. I think it's going to places that it's going to change things massively, but it's also not going to change a whole lot of things. In 5 to 10 years, the early adopters will be pushing the boundaries, but there's going to be a lot of people still, in essence, doing a set of drawings where we're probably moving beyond drawings to more thinking about how do we send the data to a machine to build what we need. And then people will be interacting with that. So for me, I think we really need to start thinking much more about the data we're creating rather than a set of drawings that we're creating. And at the moment, we're still definitely in the world of drawings. And I find it crazy that I have to have this really detailed model with all the information in, then have to put it out into these 2D drawings and send it to the council as a PDF. And then they crawl through these drawings and find all these bits that I haven't labeled correctly or got the right information, even though it's correct in the model and is right. I then have to go back and double check because I was like, oh shit, did I do that right or not? And where can we get AI to do code check, even if it's code check before it goes to someone to check? Conversations I've had with friends and colleagues, the amount of RFIs that seem to come back, if we can reduce those, that's massive. The amount of rework that we put into a project is insane. I've been working with Damon Otto, not so much recently, but on and off for the last few years on a number of things. We both worked together for Lend-Lease on a project for Google, looking at how they build 20,000 homes for their staff. And we're sort of looking at automation of mass timber, multi-story apartment buildings. From that, we sort of saw an opportunity beyond what Lend-Lease and Google were doing and how these tools can be used in different ways. And we've developed a whole process called Seed Build that reimagines the whole design and delivery of buildings. I see that as actually being the biggest game changer in what we're doing, because if we're just getting tools to do what we're doing now faster, that'll just speed up, but we're still going to have the same issues. The plumber's still not going to read the plan the way you thought they would and put something in the wrong place, or the architect is going to put something in the wrong place and the plumber's going to get really annoyed because it wasn't the easiest way to do it, so they're going to do it differently or whatever. But if we reimagine that whole process, I think that's where the big changes are going to happen, and that we then allow AI and automation to be used at their strengths rather than just create another set of drawings. But that takes a massive shift, and it comes back to your things about liability and the contractual things that go with a set of drawings and specifications. But if we have a data-rich model that has blockchain as a way of authenticity and ownership of things, then we're starting to see these shifts. And then we've got a digital twin before it's being built through to after it's being built, through to demolishing things. So there's a whole lot there, but I think everything's going to change and nothing's going to change.
Thank you, Antony. This has been really fantastic chatting with you this morning, and I really look forward to following up with you in a year or so and hear where things have moved on to, and especially interested in hearing more about your own personal project. I think we are really in need of people thinking a bit further ahead about how we can do things affordably, and as you say, like yourself, getting involved in the project and finding ways of doing stuff yourself so you can make it much more cost effective. So yeah, I really look forward to that, Antony.
Yeah, so do I. Thank you.
All right. You enjoy the rest of your week then. Sharing knowledge is at the heart of our strategy to make buildings better for everyone. Sign up for our podcast to learn more about creating healthy living conditions by protecting building structures from external and internal moisture damage. Thanks for listening. Looking forward to having you with us next time.